that's a awesome little intro to get you guys started today. But do apologize, still don't have much of a voice, so I figured I would try to make this video so that I could help you guys out one-on-one if you need it, and you guys could ask any questions that you need. If you can't hear me at all, just let me know. I can gladly explain anything on this video, okay? So, pardon me. This is a bonus section, meaning everything I'm about to show you is something that's like shortcuts. So, let's take a look. Okay, so questions, daily questions. X minus 3 times the quantity x plus 3. Still just foiling it out. X squared plus 3x. So first, outer, inner, last, minus 3x minus 9. What happens in the middle here, these two terms? They go away. And we get x squared minus 9. Very good. Much the same over here. Okay. We get x squared minus 7x plus 7x minus 49. My outside and inside term cancel out. And I'm left with x squared minus 49. Do you notice a pattern? If so, generalize to this. Simplify the expression. Now, guys, take a look at this. Okay, you've been doing this for a while. If I gave you these two problems and asked you to do difference of squares, pardon me, you would end up with the original problem. Okay? Notice the binomial. It's the same thing, just the sign in the middle has changed. Right? So if I generalize this, check out what happens. Generalize meaning simplify it. A times a is a squared. A times negative b is negative ab. B times a is ab. B times negative b is negative b squared. These cancel out. I'm left with a squared minus b squared. Okay? So, we're going to be noticing some patterns today. This is the first one. Alright, it's just when you have the same thing twice, just different signs. Now, the next one we're going to take a look at is called a square of a binomial. So if I was asking you guys to simplify this, bear with me for the variables. It'll get easier once I give you guys numbers. What this is saying is a plus b times a plus b. Alright, first, outer, inner, last. A times a is a squared. A times b is ab. B times a is still ab. Multiplication community, if I can flip it around. B times b is b squared. How many ab's do I have? 2 of them. So, a squared plus 2ab plus b squared. There is my special pattern. This is pretty neat, okay? I think I explained this in the last video, but if you ever have anything, for example, x plus 3 squared, square the first term, square the last term, and to get the middle term, you do x times 3 times 2. 3 times x is 3x times 2 is 6x. Boom, there's my answer. Little to no work. Like I said, this is a shortcut unit. We're going to see much the same over here. Foiling it out. A squared minus ab plus b squared. Okay? These two combine together. A squared minus 2ab plus b squared. Alright, there's my special pattern. The only thing that changes between the two of these is that if it's plus, it stays plus in the middle. If it's minus, it goes to minus. Alright? Here's your $1 million question for today. Does the quantity a plus b squared equal a squared plus b squared? No. No. Okay. Anybody here watch Star Wars? Remember episode 3 whenever Darth Vader gets formed? And he's like, oh, Padme passed away. And he's like, no. Just remember that. If not, I'll see if I can find a video clip of it later. You can't do this, alright? But I can almost promise you that somebody in this room is going to do this, alright? Every time you're squaring a binomial, you have to write it out as such, or do the special product patterns. Either one, alright? Please do not do this. This is bad. You don't want that, alright? I will say I told you so if you do it. Alright, on to the back. Simplify a plus b cubed. Alright, check this out. It's the same thing 3 times. Now, I can cover this up I can just do the first two. And if I know my special property, I know it's just that. How in the world did I ever get this? Just flip to the last page, the last thing we did. Now I'm going to distribute this a across. Check this out. A times a squared is a cubed. A times 2ab is 2a squared b. A times b is ab. Alright? Now, I'm going to multiply the b across. B times a squared is a squared b. B times 2ab is 2ab squared. And then lastly, b times b is just b squared. Okay? Alright. Oh, I realized what I did here. I'm sorry. This is supposed to be b squared. That makes way more sense now, doesn't it? This is b cubed. I'm sorry. My head's not really with it. Whenever I add together like terms, a cubed plus 3a squared b. These two combine together to get me 3ab squared. And then lastly, I got a b cubed. This is a beautiful pattern. It helps us out immensely. Okay, I will show you the special pattern down here. But it's real simple. A cubed plus 3a squared b plus 3ab squared plus b cubed. So when I ask you this question, does a plus b, the quantity cubed, equal this? Again, no. You can even say it in that cool Vader voice. Alright. You're going to see much the same over here. The only thing different is going to be your signs. Again, I have a squared minus 2ab plus b squared. The only thing, the reason is that it's minus in the middle is because of this minus sign. How did I get that again on the back? Now I distribute the a across. A cubed minus 2a squared b plus ab squared. Now I multiply the b across. Negative a squared b plus 2a b squared minus b cubed. Okay. A cubed minus 3a squared b plus 3a squared b minus b cubed. What do you notice is similar between these two? Well, basically they're the same values. The only thing different is the alternating sign if it's negative. So, again, does a minus b, the quantity cubed, equal a cubed minus b cubed? No. Okay. Alright. Now, I'm going to show you guys the special patterns here. Disclaimer, if all else fails and you forget the patterns, because I'm not giving you the patterns, you can do it the other way. You guys know what I mean by that. I mean you can literally write out 4a plus 5, 4a plus 5, and then you go from there. My pattern here is this. Okay, this is a, this is b. Alright, I'm doing 4a squared plus 2 times 4a times 5 plus 5 squared. The quantity 4a squared is 16a squared. 2 times 4 is 8 times 5 is 40a, and then 25. Done. Yes, I'm going to go faster through these, but that's the point of it. I want you guys to go quicker through these. The pattern here is I just realized up top here I screwed this up too. I'm really sorry, guys. I really am sorry. This should be a cubed minus 3a squared b plus 3ab squared minus b cubed. My apologies. Okay, and then this is minus b cubed. Here's your a, here's your b. 2n cubed minus 3, 2n squared, 3, plus 3, 2n, 3 squared, minus 3 cubed. One little important thing. When you're doing the a and b for these problems, for all of them, the sign is already put into your special pattern, so you don't have to worry about it. Meaning like this 3 right here, I don't have to put negative 3 in because it's already taken care of. Alright, the quantity 2n cubed is 8n cubed. 2 squared is 4, times 3 is 12, times 3 is 36. Then 3 squared is 9, times 3 is 27, times 2 is 54. and then minus 27. Okay. When you do these, you'll know you did them right if you go from the highest exponent to the next highest all the way down. It's always in standard form. All right, last two here. Same idea. This is a cubed plus 3a squared b plus 3ab squared plus b cubed. Throw everything into your pattern. Okay. And then cube this. 4 cubed is 64. 64x cubed. Alright, 4 squared is 16. This is where my head's starting to shut down. 16 times 3 times 2 is 96x squared y plus 3 times 4 is 12 times 4 is 48. I knew that one. xy squared, and lastly it's 8y cubed. This is kind of a cool problem because take a look at your variables. Your x is decreasing in value as your y is increasing, and this is what you typically see when you have two variables. So x cubed, x squared, x, and then y squared, y cubed. One goes down, the other one goes up. All right, finally here, guys, we got let's see here, a squared minus 2ab plus b squared. Throwing stuff right in. 8c squared minus 2 times 8c times 3d plus 3d squared. Alright, 8c squared is 64c squared. 2 times 3 is 6 times 8 is 48c d. Okay. And then over here we get 9d squared. Again, the same idea here goes. If you have two variables, the one decreases while the other one increases. Okay. So, guys, that's all I'd like you to take a look at. Again, quick little reminder, all right? You don't need to memorize these per se. They just help you out. It's just a shortcut. Otherwise, if you don't know the pattern, you have to write everything out and keep going that way. However, if you feel more comfortable doing that, that's totally cool. Okay. But this is what I want you guys to remember whenever you're asking yourself, does a plus b to the quantity cubed equal the a cubed plus b cubed? I'm not even kidding, that's hilarious every time. Alright. Alright, guys. Good luck. Keep up the good work. If you have any questions, feel free to ask. And as always, okay, keep up the good work. And I don't know why that makes me laugh so much. Alright. Good luck. We're all counting on you.